So in this video, we're going to talk about how to rationalize the denominator. So when you simplify radicals, another thing you have to think about is when we have a radical expression with a fraction, simplifying involves making sure that there are no radicals in the denominator. So for example, if we have the square root of 25 over the square root of 3, that we don't want that square root in the denominator. So what we're going to have to do is turn this into 5 square root of 3 over 3. So how do we do that? Well, we do that with something called rationalizing the denominator. Notice that we take the square root of x and multiply it by itself, the square root of x, we get the square root of x squared, which simplifies to just x. So we have no radical anymore if we multiply that term by itself. With nth roots, you want to multiply in a way that gets you to cancel out that root. So if we have the fifth root of x squared, we're going to multiply by the fifth root of x cubed, because then when we add the exponents, we get the fifth root of x to the fifth, which simplifies to just x. So basically, this is how we get rid of the radical. So let's use that idea to rationalize the denominator on this problem so we can simplify. So you see here, I have the square root of 5 in the denominator, so I need to get rid of that. And whenever I multiply a fraction by something, I want to multiply by 1. So that means same numerator, same denominator. Okay, so when I do that, this is going to become 2 square root of 5 over, well, the denominator is now basically square root of 5 squared, right? Well, square root of 5 squared, the square root and squared cancel each other out, so I have 2 square root of 5 over 5. So this is now considered to be in simplified form because I don't have any radicals in the denominator. So now let's try this problem. So let's rationalize the denominator here. So you see I have a square root of 7. So I'm going to get rid of that by multiplying by the square root of 7 over the square root of 7. So in the numerator, I actually have a binomial, right? I have 2 minus the square root of 3, and that entire thing is being multiplied by the square root of 7. So I actually need to use the distributive property. Okay, so I multiply 2 by the square root of 7, and I get 2 square root of 7. And then minus, then I multiply the square root of 3 times the square root of 7, and that gives me the square root of 21, right? Remember, I use the product property, and so that's going to turn into the square root of 3 times 7, which is the square root of 21. And that's all over the denominator, which is now the square root of 7 squared. So this is just going to simplify to 2 square root of 7 minus the square root of 21 all over 7. And that's now my final answer. So now let's try this problem. Let's rationalize the denominator and simplify. So you may be wondering, well, what do I multiply by? You only need to multiply by the radical part. Okay, so I only need to get rid of the square root of b. So I'm going to multiply the numerator and denominator by the square root of b over the square root of b. Okay, you don't need to worry about that 2 because you can leave the 2 in the denominator. So I have 5 plus the square root of b times the square root of b, and that's over 2 times the square root of b squared, right? Because I have square root of b times square root of b. Okay, so in the numerator, I'm going to distribute. So I have 5 square root of b plus, and then I have square root of b times square root of b, so square root of b squared. And that's all over 2 times the square root of b squared. Well, once again, that's going to cancel, so I have 2b. So this is going to equal 5 square root of b plus the square root of b squared, which is just b, and that's all over 2b. Okay, so that is now our fully simplified answer. So sometimes in the denominator, you won't just have one radical, you'll have a binomial radical, right? So you'll have like a whole number and then plus a radical, or a whole number and then minus a radical. So when you have that, you need to multiply by its conjugate. Okay, so remember the conjugate is basically the same binomial, but just with opposite sign. So if you have the radical a plus the square root of b, the conjugate is a minus square root of b. Okay, if you have a minus square root of b, the conjugate is a plus the square root of b. So when you do this, what's going to happen is you'll have no radicals in the product. So that's why this is helpful when we're rationalizing. So for example, if we have 2 plus the square root of 3 times 2 minus the square root of 3, like you can use FOIL if you want to, right? So FOIL will give us 2 times 2, which is 4. Outside is minus 2 square root of 3. Inside is 2 square root of 3. And then last is going to be minus the square root of 3 squared, which equals just minus 3. So when we add up all these terms, we have 4 minus 2 square root of 3, and then plus 2 square root of 3, and then minus 3, and these two middle terms will cancel each other out, and then we have 4 minus 3, which is equal to 1. Another way to do this is to recognize that this is kind of like a plus b times a minus b, so you can use the difference of squares to multiply these together. So remember, that's like a squared minus b squared, so you can think about this as being 2 squared minus the square root of 3 squared, which is equal to 4 minus 3, which is 1. That's actually how I prefer to multiply these, but if you want to use FOIL, that's fine too. Okay, so let's now try rationalizing the denominator and simplifying this expression. So you see here, I have a conjugate binomial, right? This is different than this other example I had because here, the 2 was being multiplied. Okay, so when you have a coefficient multiplying a radical, you can just multiply by that radical part to get rid of it. When you have something that's being added, that's actually a binomial radical, so we have to use the conjugate to simplify. So what we're going to do here is we're going to multiply the numerator and denominator by 5 minus the square root of x. So what we're going to do now is we're going to multiply the numerator, so we have square root of x times 5 minus the square root of x. And then that's over 5 plus the square root of x times 5 minus the square root of x. So in the numerator, let's go ahead and distribute that. So we have 5 times the square root of x minus the square root of x squared. And then in the denominator, I'm going to use the shortcut. I'm going to use the difference of squares. So this is 5 squared minus the square root of x squared. So this is going to now become 5 square root of x minus x over 5 squared is 25. So I have 25 minus the square root of x squared, which is just x. So this is now our fully simplified answer.